Have you ever found something that feels a bit weird, a bit odd, something that shouldn't exist, but nonetheless it does? I stumbled across this rational number while working with a student on an unrelated problem, and I've just had time to come back and look at it in more detail. At first, it doesn't seem particularly remarkable, just a positive fraction with a fairly large denominator and numerator, 2,334 and 12,387. By inspecting the digits, we can see that both numerator and denominator are divisible by 3, and with a bit more simplification, we can find that this fraction simplifies all the way down to the pretty straightforward 2/11. I recommend that you stop the video and simplify this fraction yourself, factor by factor at this point. You might even spot what I found too. Now, in my day job as a maths tutor, I sometimes feel I'm forever reminding students that the only thing they can cancel in fractions is common factors, not common features of a numerator and denominator. But in this odd case, we can actually relax this rule. What happens if I decide to cancel the digit 3 from both top and bottom? Well, let's find out. It turns out we get a new fraction, 234 over 1287. And I suggest that you stop the video here and try to simplify this too. What we find out is that 234 and over 1287 also simplifies to 2/11. But we can go further still. If we cancel the digit 2 from both numerator and denominator, we've got down to the comparatively simple fraction of 34 over 187, which, by dividing by 17, is also equal to 2/11. To me, this was really quite surprising. The fact that numbers can be simplified twice in this way was not something I'd expect, something that I would have expected. What also surprises me even further was that the order of digit removal doesn't matter either. If we cancel the 2 and then the 3, or the 3 then the 2, every fraction along the way will also simplify to 2/11. Well, why is this? To tell you the truth, I really don't know. I've actually found a few more since beginning to make this video, and they're not multiples of 11 or 2, they simplify to something else. And I've also approached the problem from an algebraic, combinatoric, graphical, and also a brute force approach, and I've yet to find a simple explanation as to why these digit cancelling fractions exist. What I do notice is that the prime factorization of both numerator and denominator tend to have a big jump in them, i.e. there's a bunch of smaller prime factors and then one which is much larger. We can see this in the prime factorizations of the original fraction. If you made it this far to the end of the video, thanks for watching and thanks for listening. I'm not a professional mathematician by trade or by training, but I am fascinated by the world of mathematical ideas, and I love stumbling across happy discoveries like this. If this video gets some good response, I'd like to make more on some of the other similar fractions I've found, how they can be generated, and what makes the problem of finding them difficult in the first place, as well as some results in their, and I'd also like to share some results about their distribution and the distribution of their prime factors. If you have any thoughts on the matter, I'd love to read them, so please, of course, like, subscribe, and comment below. Lord knows I'll need some help with this problem until I crack it. Thank you very much.